Hi everyone, and welcome to our video on adding and subtracting polynomials. We've been working with polynomials the last few days. We've been, multiplying them, raising them to powers, dividing them, and today we're going to add and subtract. But honestly, between Alex and maybe your work last year, you probably are going to find this lesson to be a review or pretty darn easy. So let's take a look at what I've written here. It says, when adding and subtracting polynomials, you may only combine like terms. I think that's worthy of some highlighting. When adding and subtracting, you may only combine like terms. Okay, so what are like terms? Well, like terms are terms with the same variable and the same exponent. So the letter must match, and the exponent that letter is being raised to must match. So let's take a look at example 1. Example 1 says, find the perimeter of this rectangle below. So we're going to have to revisit perimeter, which is probably the key word here. So hopefully you remember that the perimeter of a rectangle is found by adding up all four sides of the rectangle. So they've given me two sides, but I know just from previous work with rectangles that the length of sides opposite each other are the same length. So if this length here is 2x plus 3, then this length over here is also going to be 2x plus 3. And same here, x plus 1, x plus 1. So now if I want to add all four sides together, I will have perimeter. I'll call that P equals. I could do 2x plus 3 plus another 2x plus 3 plus x plus 1 plus another x plus 1. So that is all four sides added together. Now I will combine my like terms. So I have to find all of the terms that have a matching variable and exponent. So let's take a look here. Well, here I've got a 2x. And that x is being raised to the first power. So I'm going to try to find other terms that have x raised to the first power. So not this guy, not the 3, here's 1, not the 1, and then here's another x. So everything I've highlighted is considered to be like terms. So when I add 2x plus 2x, I get 4x, plus 1x, I get 5x, plus another 1x, I get 6x. And now my other like terms are just my constants. I have a positive 3 plus 1 plus 1. So if I add those together, 3 plus 3 is 6, 7, 8. So my perimeter is 6x plus 8. And that's going to be my final answer. Again, I can't put the 6x and the 8 together because they're not like terms. Now the other way you could have gone about finding the perimeter would have been, again, since it's a rectangle, there is a formula that looks like this. P equals twice the length plus twice the width. I'm sure you've seen this formula before. And if I had done that formula, then the work would have looked like this. Twice the length. Well, the length is 2x plus 3. And then plus twice the width. Well, the width is x plus 1. Now, if you use this formula for perimeter, then you're going to have to use the distributive property. So let's continue on here. P would equal, if I use distributive property, I'm going to have 2 times 2x, which is 4x, and 2 times positive 3, which is positive 6, and then I have plus 2 times x is 2x, and 2 times positive 1 is positive 2. Taking this expression here with 4 terms, this polynomial expression, I would now combine the 4x with the 2x, which would give me 6x. And then I would combine the 6 and the 2, which would give me 8. So either way, I'm going to get the same answer for perimeter here, whether I just add all 4 sides or use the more advanced formula here, twice the length plus twice the width. Okay, let's move on to example 2. Again, another perimeter problem. It says find the perimeter of the triangle below. Now, a triangle only has 3 sides, so I cannot use this formula here. This is only for rectangles. So for this one, I will just simply add up all 3 sides. So for this one, P perimeter will equal. Okay, so I've got 3x plus 1 plus this guy right here, 5x plus 2, plus this final side here, which is x squared plus 2x plus 1. Okay, now combining like terms. Let's highlight our like terms. So 3x is how this polynomial starts off. So I'm going to highlight the 3x. And then I'm going to highlight any other terms that just have x to the first. So I've got a 5x here, and then a 2x. So those 3 like terms added together, 8x plus 2x, let's see, that makes 10x. Then I've got my numbers with no variable attached, like this 1, and this 2, and this 1. So when I add 1 to 2, I get 3. 3 plus 1 is 4. And finally, if I grab a third color here, I've got this lone wolf here, this x squared term. There is no one quite like that term because of the squaring. And so we just bring him along down for the ride here, plus x squared. Now, you could leave your answer like this, but I would prefer that we write our polynomials, in this case our trinomial, in descending order. Okay, that's a new term here. So descending order by exponent. So I want the highest exponent first, followed by the next highest, and so forth. So if you look here, the highest exponent is this 2. So I'm going to start with x squared. From there, I've got my 10x, positive 10x, and then I'll finish with the 4. This is a really nice final answer in descending order. And what you can see here is that you've got a polynomial, which more specifically is a 1, 2, 3 trinomial, whose degree is 2. Remember, the degree of a polynomial is the highest, the degree of the highest term. So the highest degree of any one term here is 2. So the degree of this entire polynomial is 2. And I like to see that right in the front. Okay, very good. All right, next one, example 3, last one on this page. This one says the lengths of 2 sides of a triangle are given. And you can see them right here and right here. If the perimeter of the triangle is 10x plus 5y, then find the length of the third side. So this is interesting. This time, they give us 2 sides. They want this third side. That's the question. What is this third side? So that the final answer for perimeter is 10x plus 5y. Okay, so here's what I'm thinking. In these other ones, these other examples, I put P for perimeter. P equals, P equals. Well, now I have the perimeter. The perimeter is 10x plus 5y. So I'm going to write 10x plus 5y equals. So this would have been P, but they're giving me P. And now I'm going to add these sides together. So I've got a 3x plus a 4y plus a 5x minus a y plus this question mark, which represents the third side, which I don't know. And all together, when I add the three sides, I'm going to get 10x plus 5y. So let me combine my like terms so far. So here's 10x plus 5y. I'm just going to bring that down. Okay, let's combine the like terms that I've got here. So I've got a 3x and a 5x. So that's going to make 8x. And then I have a 4y minus a 1y. So if I take 4y minus 1y, I have a positive 3y. And I still have to add that third side, question mark, to get my perimeter. So now it just becomes a little bit of a puzzle. So you got to ask yourself, the final answer for perimeter has a 10x on it, but I've only got an 8x here. So how many more x's do I need in this question mark so that when I add together my like terms, I get a 10x? And you can pause the video here if you need to think about that. But when you return, I hope you're thinking, let me grab a different color pen here. I hope you're thinking 2x. So part of this question mark has to be 2x. Now, 3y has to become this 5y. So what more do I need? I need more y's to get to a 5y. Well, how many more? Well, you already have 3, so I'm kind of thinking we need 2 more y's. So if your question mark is equal to 2x plus 2y, then when you combine your like terms, there's your 10x and there's your 5y. So I would say that the length of my third side here is simply 2x plus 2y. Very cool. Okay, there is one more problem on the back, so let's flip this over. And this one doesn't have a picture. This is just a little bit more straightforward. It says subtract the polynomials given. Okay, so we have a trinomial here in the first quantity with degree 2. And we're subtracting another trinomial of degree 2. And they want to know what the result is. What's the difference of those two polynomials? Well, the difference between anything we did on the front and what we're about to do on the back is right here. I'm going to highlight it. It's the fact that we're subtracting now, not adding. And there's a little hiccup that you have to remember whenever you're subtracting one polynomial from another. And that is the distributive property. You are minusing this entire quantity. And therefore, this minus sign must be distributed all the way through this quantity. So if you think of this as a minus 1 sitting here, you must distribute here, here, and here before you are allowed to combine any like terms. So what I like to do is rewrite my problem after distribution. So what I'll do is I'll just carry the front down. 5y squared plus 2y minus 2. So nothing changes. I just sort of drop the parentheses. Now, negative 1 times 3y squared is negative 3y squared. Negative 1 times 7y is negative 7y. And negative 1 times negative 8 is positive 8. And once you do that, you're home free. And we start to highlight like terms. So I've got a 5y squared. And the only other term that's got the same variable and exponent is right here. Take the sign with it. So 5y squared minus 3y squared is 2y squared. Okay? Now, next we have a positive 2y with a negative 7y. And so that will be negative 5y. And last but not least, I have a negative 2 with a positive 8. And that is going to be positive 6. And so 2y squared minus 5y plus 6 is my final answer. Now, while I have you here, I want to go over just a little side note as we move through this chapter, as we've been doing different operations with polynomials and monomials. I just want to make one thing really clear. There is a huge difference between adding like terms, or you could be subtracting too. So adding or subtracting like terms versus multiplying. And I can even put here like terms because I think this is where you would get mixed up. You would look at two like terms and want to add them, but you would do the operations of multiplication. So let me give you an example here. So say you were adding these two like terms. Let's say 5x to the third plus 11x to the third. Now from the work that we just did, when you add, or subtract for that matter, like terms, the variable component of your monomials, so the x to the third and the x to the third, that just comes along for the ride, stays exactly the same, and you add the coefficient. So the final answer to 5x to the third plus 11x to the third is just 16x to the third. So you had 5 of these, and you added 11 of these. So now you have 16 of these, okay? Here's where it gets confusing. If I ask you to multiply these two like terms, right? 5x to the third times 11x to the third, we know by the product rule that 5 times 11 is 55. And that when we add these exponents, we get x to the 6th. And if you break things down because you don't like shortcuts, this is 5 times x times x times x times 11 times x times x times x. And so there's your 55 and your 1, 2, 3, 4, 5, 6 x's. Here's what I've seen. So why am I bringing this up? I have seen people accidentally say that 5x to the third plus 11x to the third is 16x to the 6th. Like they'll add the 5 and the 11 and then they'll add those exponents like they do down here. That's a big fat no. No, no, no. You got to keep this straight. So when you add or subtract, keep the variable and its exponent the same. When you multiply, that's when you add up and tally up all the x's. So just some food for thought as we're working through this chapter with all these different rules. Okay, thanks for watching.